Good afternoon, good evening, good morning, wherever you are in the world. Welcome to SurrealDB stream number 29. I'm joined today with Micha, our engineer who's been focused a lot lately on the graph algorithms and the graph functionality that we've recently added into SurrealDB. So, welcome wherever you're listening in from. If you're on YouTube, Twitter, LinkedIn, do comment, do add some comments, and we'll try and answer any questions that are coming up on the stream as we go along. But today, we're going to be looking at a new feature that we built into SurrealDB 2.2, and it is called record links and record references. So record links is what we had before, the ability to jump directly between record to record, and record references makes this just far nicer. So Arvi Dend, welcome from South Africa. Great to have you with us. And so, Micha, I think what we've got to first do is go back to the very beginning and say, what are record links? How do they differ from joins in a traditional relational database? What can you do with them? We'll also then look at what's the difference between record links and graph edges or full-on graph relationships. And then we're going to take a step back again and say, what is record references and how does that kind of change the game if you want to simplify your graph and your relationships? So for those of our kind of viewers listening in today or people watching this in the future, what is the difference? What's the benefit to modeling data with record links rather than integers and columns in a traditional relational database and then using joins?
Right. So usually in the database, you would need to basically define an index for quick lookups, right? So let's say that you've got an ID field on your table or whatever, maybe an email as a lookup key. And you would define an index on that table, which allows you to do quick scans essentially over the table because you just iterate over the index instead of the whole table, right? However, with record IDs, which is what's really cool, is every record in SurrealDB has a record ID by default. This is actually how they are stored in the underlying KV store as well. And what that allows us to do is, let's say that we want to grab a record for person Tobie. We just say select everything from person Tobie, and it will just go into the key value store, grab just only one record, and give it back to you. So the lookups get much quicker that way.
Yeah, I think just listening to you talk about that, I think we have to jump back a little bit further. And for those of us, our users who are coming to SurrealDB for the first time, what is a record link itself in terms of the ID, and how is that different from a traditional database? So in MongoDB, you have the ID field, which is an object ID. You have classes and IDs in Neo4j. In relational databases, you have an ID field, usually an ID field. In SurrealDB, you've got an ID field as well, but the ID is not what you'd expect when comparing it to other databases. So what's the difference in SurrealDB with record IDs, and what can you do? Like, what's some of the magical stuff that you can do with them?
Yes, so that's interesting. So usually you would just have a field which you can decide yourself, any field on a table, right? And you could put an integer on there. You could put a string on there. You could put any piece of data on there, essentially. And with record IDs, we actually combine the concept of basically we tie the table and that specific ID together. So essentially, this looks like table colon some ID, which could be an integer, it could be a string, it could be an array, an object, UUID, a lot of different, any value inside that array or object, which you would want.
I'm just going to jump in there. Arvi Dend, this is not record IDs. We're just looking at the basics in SurrealDB first. We'll be jumping onto the new features and the new functionality called record references in a little bit.
Absolutely, yeah. And so it's essentially table name colon some ID by which you want to store that record on your table, and that allows you, as it's part of the query language, to very easily and quickly do a lookup for that one specific record.
Yeah. So the record IDs themselves are very flexible, and when you store record links between, let's say, two records in the database, that enables you to do the storing of relationships up front, albeit they're single direction, right? So if I have product A and I have user A, if user A owns that product, then I can traverse out from the user to the product table, but I can't traverse back. The product doesn't know that it is owned by the user. So we then have graph relationships, and that enables a completely different, much more verbose functionality where you can do far more. So let's jump a little bit forward before we come back to record references and say what's the benefit of what you can do with full-on graph relationships and graph edges compared to just single record links.
Yeah. So essentially, an easy way to think about graph edges would be as a many-to-many relationship, right? So you can have one node which connects to sort of many different relationships, and then that table, you can have different nodes in there which also connects to different tables. And what's very interesting is on the sort of the edges that join those two records together, you can put any form of metadata on there. So you could say this record or this relation was created on this time, and it was last updated on this other time. Maybe you want to put like let's say that it's an order, so you can put products on there or all that kind of information. So it allows you to how do you say it? It's very flexible in what you can do with it.
You can traverse bi-directionally, right? So you can a product could be owned by a user, and a user could own a product, and you can traverse both ways. But that comes with a cost, right?
Yeah.
So you then have to insert more edges. There are 3 tables involved. There's the first table, the second table, and there's a middle table, effectively the third table, which is that relationship, that edge between those 2 tables. And then in between there, you have to create the links themselves, the links that point out from those tables and back in. Record links enables you to do a lot of this in a scalable way, and enables you to do it in a more simple way as well, right? So let's start with the basics, because record references it's a powerful piece of functionality that enables you to have improved data integrity, constraints on what you can do with the data, which is something you couldn't do before. So we'll come back to how you did it before, but let's start basic. What are record references?
Yeah, right. So as you said, with a graph relation, what essentially happens is that under the hood, we create a set of keys in the key value store. So that's from left to middle, middle to right, and then also right to middle, middle to left again. So that allows us to do the bidirectional lookup. And that is something, basically bidirectional lookups is something that you couldn't really do with record links previously. Now, however, what record references unlock is that we allow you to create that link back. So let's say, if we can pull up my screen, let's say that you have got create city, let's see, London, and now let's do a create person Tobie, and let's say that he lives in city London. So now we can very easily do a lookup for person Tobie in which city he lives, but we cannot very efficiently right now do a lookup for select people from city. So we cannot very easily see which people live in city London
Without doing a full table scan.
Yep, exactly. Or maybe we iterate through an index, for example. But what we can do now is, let's say that we on person table or on table person, we can define a field for city on person. Let's say that it's a type record city. And what we can add there now is we can add a reference keyword. And what that will do is that will create a link back from city London to person Tobie. And that then unlocks us to very efficiently, for example, do city London, and then we can get the references for that record ID, and then we'll get back person Tobie.
So I think, importantly, one of the questions we're going to get from users is why. Right? You can do this with graph relationships. What's the benefit to this? So there's obviously a performance benefit that we can talk about. actually, let's start there, right? So what are the things that, as a user, you have to consider when you're using graph relationships? What are the benefits to it? When should you use it? When should you not use it? I think that's where we should start. So when you're using full-on graph relationships, you have the ability to traverse bidirectionally. That's something that record references now gives you. What record references doesn't give you is the ability to store metadata on the relationship. So as you can see here, Micha's added person Tobie, city London. There can be no information on that relationship about when I started living in London or where I'm living in London. It's just two things linked together, which is definitely in certain situations that's exactly what you need. You don't need more than that. With graph relationships, you can store a whole load more information. So that effectively there is a table in between which has any metadata you want to store on it. So because of that, Micha, we'll jump into the performance impact of record references in a bit, in kind of how it is different to just record links themselves. Because as a user, you always want to be able to know what that cost is when you use a feature in a database, right? But in terms of the graph relationships themselves, you have three tables. So you have the person, lives in, city. So there are three tables. The lives in is the one that's going to be created for that relationship. And then in between those three tables, so one table is modified, the other two aren't modified. But you do then have a connection from person to lives in to city, and additionally from city to lives in to person. So effectively you have 5 edits to the underlying storage engine. Whereas with record references, that's completely different, Micha. So let's try and analyze what are the implications and what's the impact from record references over just a single link itself.
Yeah, so I mean, this creates back just a single link, right? Instead of those 4 links that we've got here. So we'll have one link on the person Tobie record, which goes from the city field to City London. That's the link to City London. And now under the hood, we'll also create a link back to you. And I think very interestingly, what that allows us to unlock is referential integrity. If we want to jump in there already. So what we can very easily do now.
Let's come back to this in just 1 minute. So
yeah,
effectively, just to confirm, so where with a graph relationship, obviously you have much more flexibility, much more control. You can have multiple relationships. You can have metadata or data stored on that relationship. But effectively, you have 5 or 6 writes additionally to the storage engine. Whereas this you just have 2: the record being updated and the inverse relationship, the inverse reference.
That's correct. Yeah.
So as you mentioned referential integrity, constraints, data integrity. That brings us onto that topic. So with this reference that now points back to this record, what can you do with it?
So I think one very interesting thing here would be we can actually specify on delete reject. So now let's say that at the end here we try to delete City London. We can actually run this now, I think. We can see that we cannot delete City London as it's referenced by person Tobie with an on delete reject clause. Because obviously, we cannot just delete a city if people still live in there. And there are a couple of other ones there as well. Just thinking, we can also, the default would be ignore.
So that would enable you to just delete it, and the referential integrity is gone, as it were.
Yeah. So person Tobie with City London will still exist, but just the city record will not exist anymore. We also have the ability to, for example, cascade. So now, if we delete City London, what will happen is that person Tobie also gets deleted, essentially.
Amazing. So this was possible in prior versions of SurrealDB, but you had to effectively build it yourself, right? How were users doing this before? And this is incredibly simple, right? The ability to just say reference on delete cascade or reference reject. What were people doing before in order to do some of this functionality?
So people would mainly be using events for that. So let's sketch an example here. On the city table, we would have needed to define an event. Let's just call it cleanup for example. So we'll do it on the city table, and then when the event is delete, then we can delete person where city is let's say before.id. And this would have cleaned that up, but now you need to iterate over an index. You need to you need to build all of this stuff yourself. Whereas with record references, this is obviously a lot easier to do. So you just reference on the lead cascade and you're done.
Yeah, this is powerful, and the fact that it's more performant than graph relationships purely because of what it can do, and its limitations, of course, but because of what it can do. This opens up a whole new set of possibilities for users, right? So one thing off the top of my head I can think of is usually in a software as a service platform or some account-based platform, you have an account table, and the account table has the different accounts of the organizations who are signed up to your system. Now, you may want to delete all data from all of your other tables in that system when an account is deleted. But currently, you have to... There are varying ways of doing it, as you say, with these events, or you can go and run queries themselves. But with delete cascade, you can then go through and, similarly to how you can do it in a traditional database, you can delete all of the other references of any record that's pointing at that table without it actually having an impact on the performance when you're adding data.
Absolutely.
Now, the big question I've got, because this is one of the biggest challenges of building this feature, when you're looking at a database like Postgres or MySQL, you don't have nested columns. You don't have arbitrary arrays or arbitrary depth objects. So how is this same functionality that you've demonstrated here able to be used inside objects and arrays, nested objects and arrays in a record? And does it work the same way?
Absolutely, yes. It works absolutely exactly the same way, actually. So let's say that we've got a address field with a city field embedded in there. We can simply change this to address.city on table person. And we can now also say set address.city to city London, and it will work exactly the same way.
That's amazing. So this effectively, if using SurrealDB as a pure document database, this enables you to have referential integrity, to be able to split your data across tables, to join them when you need to not join them when you don't, to have that referential integrity as you expand across tables, to traverse out but also traverse back in, and yet to do all of that in a performant way without needing to use graph edges, which you can add if you need to, but you don't need to add. What else are we missing? What else can you do that we haven't described yet?
There is one other pretty cool thing. Is let's do a little blog example. So let's say that we've got a table tag, and let's just create a tag like create tag SurrealDB, and let's create a tag multi-model. And now we'll also have a table post, and this post, so let's say define field tags on post. This post can have tags, right? So that will be an array of tag records, because we can have a lot of different tags assigned to one different post. And what you can do there is you can also reference back, create references for all those different tags. So you can find posts by tags, for example. So let's say reference, but now what we can do on delete is we can also say onset. And what that will do, let's say that we've got this post here. So let's create post SurrealDB, and let's set the tags to tag SurrealDB SurrealDB and tag multi-model. Now, when we delete one of those tags, let's say tag multi-model, what it will do is it will go to this post SurrealDB and it will alter this array to just unset. Actually, I'm saying this wrong now, because that is just saying this wrong right now. Hold up. Sorry, actually. Unset, what that will do is let's have this tag field on post and let's make it an optional record.
It would unset that to a none. Yeah.
Yeah. So let's make it like this. Let's just adjust the demo real quick there. So now when we delete the tag multi-model, it will set this tag field to none. So there's no need to delete the entire record. So like Cascade, for example, you can just unset that one field and it's completely fine.
So that's powerful. So we've got the ability for references to work at the bottom of the at the base of the document, or in arbitrary depth objects and arrays.
Yeah.
We have the ability for prevention of deletes, so rejection. We have the ability for cascading of deletes, so deleting continuously up the chain. We have the ability to ignore, which will mean which is the default right now, which is you're ignoring referential integrity guarantees. And then we have the ability to unset a field, which is an optional field, to make it, to take it from something to nothing. Actually, when that record ID no longer exists.
Just thinking about it, I was correct with the multiple array tags as well. You can actually do that as well, because it will just unset one of those fields in the array.
And so unset in an array of records will actually remove that record from
that
the
one single tag. Yeah.
From the array. So this is actually very similar to cascading deletes and referential integrity inside relational databases, but with the ability to handle more in a graph-like way, because obviously we can traverse tables out very easily without joins, but to also handle nested object data and nested arrays as well.
Yeah.
So I think the next step of what we should look at is a couple of questions from the community. So Prazan says, good, it can be applied to real work such as healthcare systems, which would be great. So yeah, this is an incredible feature that opens up how you can use Surreal, but also kind of locks it down in terms of the guarantees around your data. So this is an incredibly important feature for us. It goes alongside some of the other functionality that we'll be talking about in the next stream next month and the stream after that, which is a massive improvement in the functionality around graph and graph querying. This is just the first step. This is something we've always wanted to add, but we were never quite sure how to do it in an easy way. And then Micha came up with this idea, which effectively simplified this with just a single keyword. So just using the keyword reference. Now, importantly, under the hood, you don't have to think about any of the data or the linking or anything like that, which you had to before. You can now directly benefit from the inverse relationship, the added performance over graph relationships. Again, it's not a replacement for graph relationships. It's a replacement for, a lot of the time, users were using this functionality but having to do it manually. That's what it's a replacement for. And in addition, if you have lots of just kind of single pointer relationships that you don't need to store metadata on, you don't need to have a separate table record in between, and therefore you want to improve that performance, this is now that piece of functionality. So it guarantees a lot about your data. It means that, as you say, this can now be used in real systems where you need to know and understand how that data is stored over time and that it is accurate and up to date. So yeah, definitely, really, really excited about this feature. I've got a question from It's Jimpex in the USA. Hey, welcome. Great to have you with us. So it might be something that you will answer anyway, but if you have a reference on a table, does it auto-fetch the record in any query? So it's an interesting question. If I understand what you're asking correctly, and maybe Misha's got a different thought for this, but So when you have a reference on a table, for instance, in a record ID, it doesn't necessarily fetch that unless you want it to fetch it. So there are lots of different ways, and this is the magic of SurrealQL, but also, I guess, one of its downsides in that there are so many different ways of explaining how to do something. But if you want to fetch a record ID, you can either, and again, Misha's going to demo this, but there are lots of different ways of doing it. So you can either traverse out and you can fetch a field from that record ID. And so this is a different thing. Yeah. So, Misha, what are your thoughts on this?
Yeah, so it won't auto fetch the record if you mean, like, for example, here it will not auto fetch City London, for example. That doesn't change at all. What you would do there is you could, for example, select city from person Tobie.
That wouldn't fetch it either, would it? That's just going to fetch the record link. Yeah.
Fetch city. However,
so just before we carry on there, it's probably important in case we're looking kind of a bit too deep into this question. It's important to note the different ways of doing that. So you can either say fetch city, you could also say city.name, and then you could also use destructuring as well, right? So you could say even just select city.name from person Tobie, or select city dot and then the brackets, right?
Yeah. Absolutely. Yeah, so you could do that here, I believe. I don't think we actually support destructuring in the fetch class, interestingly enough, but that's definitely something we should add.
Name and then, I don't know, geolocation.
Yeah.
So this, when you're fetching the person Tobie record now, we then go and fetch the city record, we pull it from the storage engine, and we pull out just the name and the geo fields from that record, and that's what we return. So if you're in a similar way to how you were doing it before, if you're querying a record link, or if you're querying a record which has record links in it, maybe at the base of the record or in embedded objects and arrays, we don't fetch that automatically. You have to still specifically say that you want those, whether that's through destructuring, whether it's through chained links of record IDs, whether it is through the fetch clause or anything like that. So there are lots of different ways of doing it, but it doesn't automatically do that for you. And again, that's down to performance. You as a user should be able to choose exactly how you want to query your data and when you want to query that data.
Now, I think a different way of thinking about that question, because that's how I initially interpreted it, is if it's possible to automatically fetch basically the people that live in that city. And yes is the answer. So you can use that refs method. In fact, you can even go more granular and say, I want to get just a reference from the person table, or maybe even just the address.city field on the person table. But you can also make a automatic sort of fetching like this. So normally, I think what you would do here is you would use a future to sort of fetch all of these backlinks. But now with record references, you can also have a special references type on that city table with, so let's say, a people field. And now if we query everything from city, we will also get that person Tobie back there. It will just do it automatically for you on the fields of that table.
It's a powerful feature, that. So the refs function enables you to either put out all references, which there could be billions of them, right? There could be millions of things pointing at a record.
In which case, you definitely don't want to use a type.
Or you want to filter on that, right? Yeah. Can you filter further down than that?
As in,
can you filter with a where clause potentially, or do you have to filter through all of those record references?
Well, what you could do there is you could, for example, do a select everything from that city London, and then add a where clause in that statement, where you can add more granular filters.
Awesome, that's powerful. We've got a question here from Chase. Chase, great to have you here, wherever you're listening in from. So, is it possible to have record references to edge tables, and what are those dynamics with deletes? So let's answer the first question first. The beauty of everything in SurrealDB is it's just a table. It's a collection if you come from MongoDB World. It's a table if you come from Postgres or MySQL. But effectively, it's a table. That's what we call it. So that table, which is the let's say person likes person or product user buys product, that buys table is a table itself. You can link to the records in that table. So absolutely, definitely, you can link to edge tables. If you have full-on graph relationships and you want to link specifically to the edge in those relationships, then you can do that. Micha, what are those dynamics with deletes?
I am not 100% sure. Is that like Cascade and those ones?
Let's talk about Cascade. Chase, if you could confirm what you mean by that question, we'll change our answer or answer it differently. But yeah, so what are when you're deleting records, let's say, and it cascades deletes, what are the implications of that from a performance perspective? Or actually, is it negligible compared to doing that manually, let's say?
Well, I mean, if you now delete, for example, City London or any record for that matter, we will have to do that scan to see if any record still reference that City London record, for example. So yes, it does have a performance impact, but I think that scan always happens now, right? So it's there are a couple of checks under the hoods which happen by default in SurrealDB. Yeah.
Yeah, Chase, to expand on that, it's probably interesting to talk about how this is actually stored in the storage engine under the hood. So in a similar way to how graph relationships are stored, where we have a first table, a middle table, and a last table, and we have effectively 4 connections between those connections, between those tables. Here we have a single connection, but that is stored in a large list. It's a list that we can jump directly to the middle of if we need to. It's a list that we can iterate through either in a forward directional manner or in a reverse manner, but it's a list of relationships. So when you delete a record, we go and check that list, as it were, on the storage engine to check if there are any more references that need to be deleted. We then will traverse up to the record above that it references, and then we'll traverse over anything there. So there is a range scan on the storage engine in order to pull out any references that might exist, and then we use the schema to define or determine what happens when you delete that record. But the performance impact is negligible. We already do that for graph relationships anyway, so this shouldn't affect anything. As you know, you might have heard, we released performance benchmarks last week. We're iterating on our own performance benchmarking tool called CrudBench, which is fully written in Rust. And you can see that deletes are slightly slower than creates and updates purely because of that range scan that we do that you don't really have in a database like MongoDB or MySQL or Postgres. But really, they're still fast. And 5 million in under a minute, it's still very performant. So it's not something you need to worry too much about. So Chase has followed up. So I just hear about record references and graph edges as an either or decision. I was wondering about potential use cases for overlap. It's a good question. It definitely comes back to what you need to do as a developer and how you need to query your data. So if you, and I guess also the performance impact, right? Writing to full-on graph edges is not slow by any means, as we've shown. SurrealDB is fast, especially when it comes to writes. However, you're writing more data, so it will be slower than when you're dealing with record references. However, if you need to be able to query in a bi-directional manner whilst also filtering on the edges or the relationships based on maybe filtering on the metadata in that relationship itself, then that's where graph relationships come into their own. I would say the next stream we're doing next month, we're going to be looking at some of the new functionality that we've added into graph relationships. We're talking about record recursive traversal. We're talking about shortest path. We're talking about Micha. What else? What else are some of the new functionality? The ability to filter on the edges themselves. So filter and ordering.
Yeah, I think recursion, generating trees from relations, shortest path, and collecting paths, for example. There's a lot of new graph functionality that we've introduced, and we're gonna go over.
Yeah. So Chase, that it really comes down to what you need to be able to do with that data in terms of when you're querying it. there are lots of scenarios where record references make sense. You don't need to have the ability to query in a very flexible, dynamic way with arbitrary depth or recursive queries or calculating shortest path or generating a tree. But you do need to be able to work backwards. And that is where references come in a performant way. The moment you need anything more than that, and anything more than just the referential integrity that references give you, then you want to benefit from the graph edges. You want to benefit from all of the different ways of querying, filtering, ordering, pulling out particular record fields from foreign records in the edge table and things like that, and also filtering on those as well. So definitely a difference. But as you say, it's interesting. I don't think I've ever thought about it in that way. You can use these record references to link to edge tables and have a hybrid approach where you're making the best of both worlds, as it were. So yeah, that's an interesting take on it. If anyone's got any other questions while we're still talking, then fire away, whether you're on YouTube, LinkedIn, or X. But yeah, Micha, I guess the question that users are going to ask, and obviously we'll leave off the edge functionality here because that's for next stream, and as I say, we'll look into many of the full-on graph functionality improvements at that point. But what is missing that we didn't quite get into this release, or we want to add in the future, or is there anything that's missing?
Well, that's a very good question. I think something. Well, with graph in general, right? I think record references they're pretty easy and pretty neat functionality as they are right now. But talking about maybe more graph in general, something that we would like to work on is to add more algorithms to work with. You can see Neo4j has a lot of built-in functions and functionality to work with different algorithms essentially, and we've made a start with that in the 2.2 release with shortest path and collecting paths and all that sort of all those new functionalities. But yeah, that's definitely something that we want to expand on in future updates of SurrealDB.
Awesome. So if you've listened to this for the first time today and you've heard about this new functionality that we released in 2.2 last week, give it a try. Let us know your thoughts. We're super pleased with how it's implemented in terms of the query language and the schema, the referential integrity it delivers to you as a user, or you as a developer or an engineer or an organization, and also some of the additional queries that you can drop. You can drop the define event, which was sometimes doing this functionality manually, whilst at the same time actually not really affecting performance at all. This is effectively just 2 single writes to the underlying storage engine as opposed to 1. And I think that is really impressive, whilst the benefits it brings are truly kind of important to the applications that developers are building, especially if those applications are being used in industry, in government, in medical situations. So great functionality here. As I say, next stream number 30, which is next month, we will be looking at some of the advanced graph functionality that we've built into 2.2. And then a month after that, we'll be looking at the visualization functionality in Surrealist and how you can use that to improve your querying and improve the visualization of your data as a whole. But if you're interested in the differences between references and graph and what you can truly get out of graph, as I say, we've introduced recursive graph functionality, recursive traversal. We've introduced arbitrary depth traversal as well, being able to query as many times as you need to fetch or to find the relationship to a particular record. We've introduced shortest path calculation as well, and then we've introduced it's a really impressive piece of functionality where you can actually build a tree. Potentially that's for whether you're analyzing fraud and fraud systems, whether you're analyzing relationships between people, relationships between systems. This tree enables you to visualize things in a very different way, and you can now do that very simply in SurrealQL with just a couple of extra keywords. So really cool functionality we'll be talking about in our next stream. Other than that, if you're on our Discord, share with us how you're using this new record references functionality. If you're not on our Discord, definitely join our Discord. It's a great community who are always helping out people, and a lot of the SurrealDB team are on there helping out as much as we can. So great to have you with us today. Thank you for the questions. Micha, thank you for, first of all, building this functionality for record references, but also thank you for joining us today and explaining some of the intricacies of what you can do with it. I'm sure we're going to have more questions down the line about this functionality as people start using and building against it. But as I say, it's been great to join you today on Stream 29. Have a great day and great night wherever you are, and see you soon. See you.